43, you're going to look at the different types of polygons. So for here, you can see we have two different types, the convex and concave. And if you look at the different examples, they are quite different. What makes them different is that if we look at the interior angles of any of these, you can see that they are all less than 180. Each of these angles are all less than 180. Basically, they're not a straight line. Okay? If we look at some of these concaves on the interior angles, you can see right here is way more than a 180, right? This is almost a full circle. So these are more than or greater than 180 degrees. And we're looking at the interior angles. So like right here, if you just have one angle of the whole shape that's more than 180, this has several, then we consider that concave. Another way of looking at it is that if you connect 2 points and they go to the outside of the shape, so if I connect here to here, you can see how the line is on the outside of the shape. That also makes it concave. There's a couple of different ways of looking at it. Okay. Then we have what we like to work with most often, which are regular polygons, which just mean that all the sides and all the angles are congruent. Okay. So because if they're all congruent, we can actually calculate what each of these should be based upon the formula that we learned on the last assignment. Okay. So just to review that, if we have a pentagon, which is 5, right, and it says it's regular, then we know each of these are congruent to each other. Then we can say, well, they all add up to the same amount, which is going to be 5 minus 2 times 180, okay, which we saw yesterday. 3 times 180, which equals 540 degrees for the whole polygon, right? Which means each individual angle is just going to be 540 divided by 5. And that comes out to be 108 degrees. So each of these right here are 108 degrees all the way around. Okay. There we go. And if we added those all up, it would come out to the 540. Okay, so let's just practice a few more. We have a 1, 2, 3, 4, 5, 6, 7, 8, 9-sided. So I'm going to find how many degrees total first. So that's going to be 9 minus 2 times 180. 9 minus 2 is 7. So 7 times 180 will come out to be 1,060 degrees total on the interior here. And then divide that by 9. Got 9 sides total, which means each one of those is equal to 140 degrees. Each of these is about 140, not about, but exactly 140 degrees. You can see that if we extended each one of these, that would be 180. That'd be a straight line, so that looks about right. It's about 140. All right, and then this will work with any number side shape, so even if we don't have a diagram of it, if it's regular, which means all the angles are the same inside, and we know how many sides there are, we can calculate this. So we can do 15 minus 2 times 180, which will just be 13 times 180. And 13 times 180 comes out to 2,340 degrees total. 2,340. And then we can take that and divide by how many sides we have, right, which is 15. And that comes out to be 156 degrees. Now, each one of these came out to an integer whole number, but these can be decimals as well. It doesn't have to be a perfect number like that. All right, so that's a little review from yesterday and the difference between the convex and concave. Okay. Let's look at something called exterior angles. Okay, so we spent a lot of time thinking about all the 3 angles on the inside here, the interior angles, but we haven't looked at what happens on the outside. So an angle formed by one side of a polygon and the extension of the adjacent side Okay, that's an exterior angle. And what happens is that they end up forming, if we extend this right here, okay, we call this right here the exterior angle. Okay, it's just on the outside, so formed by the extension of an adjacent side. So this is the adjacent side right here, and this is the angle we're calling an exterior angle on the outside of the triangle. So it's formed as you can see, between here and here, since it's a straight line, this is a linear pair. Okay, with the interior angle. So let's apply the idea of exterior angles to, let's say, this equilateral, where each one of these is 60 degrees. Okay. So if we extend all the way, and this is a linear pair, that means this is 120 degrees, right? That's that exterior angle. This one would also be 120, and this one would also be 120. So if we add up all the exterior angles, 120, 120, and 120, that gives us 360 degrees. Okay, which is quite interesting because the interiors are 180 degrees, but the exterior angles come out to be 360, which means, of course, each exterior angle is just 120. Okay. And if we keep going through each one of these, like let's say this is a rectangle here, and we did this over here, well, this is going to be 90 degrees, 90 degrees, 90 degrees, and 90 degrees. So all the exterior angles here of this four-sided polygon are also 360, which is quite amazing because you get the same amount for a triangle on the exterior as you do for the squares. And that makes each one of these 90 degrees, of course. If we looked at a hexagon, right, we found yesterday that each of these interiors are 120. Right? So it means the exterior here is 60, 60, here I should go that way, 60, 60, 60, yeah, and 60, right? So we go 60 all the way around, 6 times, well 6 times 60 is also 360, right? So each of these is 60 degrees, and they add up to 360. So it looks like it does not matter how many sides the shape is, the exteriors always come out to 360. And there's a close relationship between this and the reason why a circle is 360 degrees as well, because if you go on the outside of a circle, that is also 360. So it turns out the 360 works not just for circles, but for any shape, completely any shape that is which is convex. Right? It doesn't work for the concave, but for the convex it does. Okay, so quite interesting pattern we find there. All right, so we have a few theorems. We have the remote interior angle theorem and the exterior angle theorem. And it's going to just help us calculate a few things. All right, so the interior angle of a triangle that is not adjacent to the given exterior angle. Okay, so we're talking about right here, which is the exterior. Right, these are called the remote interiors. Okay. Angles. Okay, right here and right here. Okay. And all we're going to use this for is the idea that we have a theorem that says, well, if we have this angle here, okay, and we have the two remote angles over here, C and D, right, that those are actually going to equal one another. Okay, and there's various ways to show this, but basically the measure of the sum, right, of the measure of its remote interior angles. There we go. Basically, since all these add up to 180, and these are a linear pair, which also add up to 180, we can just substitute out and say, well, this big angle is going to add up to whatever these two are. So this is an angle 1. So basically, angle 1 is going to end up equaling angle C plus angle D. So if we ever want to find something from the outside here, we can actually use two angles from the inside. And that's what we're going to do right here. Just practice a little bit. And if we want to find these two, there's a couple ways of doing it. Right? We could just say, well, all three of these add up to 180. Subtract this from 180, but then this will be 180 minus this. We're just kind of bypassing that middle step. Instead of trying to find this angle, then subtracting from 180 to get this, we already know that it's really just going to be the sum of those two remotes. So this is just going to equal 60 plus 55 right here, which is 115 degrees. Right? And we can verify that if we wanted to, that this right here is also 65 degrees, but this is a linear pair and will come out to 115. And so just getting good at this. So here's the remote angle on here, and here are the, here's the exterior angle. Here are the two remotes. So we're going to, let's call that X. We'll have 150 is going to be 44 plus X, and you can just solve for X there. That'll be 106. Okay. Here's some with some algebra. So 145 will add up to be 2z plus 5z plus minus 2. Got 145 equals 3z minus 2. So 147 equals 3z, which means z equals 21. There we go. And it says find the measure of angle B. So it looks like B is right here, which is equal to 5z minus 2. So this is actually going to be 5 times 21 and then minus 2, which is, let's see, 105 minus 2, 103 degrees. And that looks about right. This is bigger than the 90-degree angle, so a little bit bigger is 103 degrees. So on this one, we'll have, this is the exterior angle, and we're going to want to find what this equals, PRS, and that's going to be equal to the sum of these two angles right here. So we can do 3x minus 8 equals 90, right, 90-degree angle, plus x plus 2. Do a little bit of solving. So we'll have 3x minus 8 equals x plus 92. And we'll add 8 to both sides and subtract x on both sides. So we'll get 2x equals 100. Divide both sides and we'll get x equals 50. There we go. So to find out what this angle is, we can just plug in 50. Just be 3 times 50 minus 8. So 150 minus 8 equals 142-degree angle. Okay, so that's what this is, 142-degree angle. And that's what these add up to as well. If we plug it back in here, this would be 52, right? And 90 plus 52 is also 142. So two ways of doing this. We could have, instead of plugging in 50 for here, we could have just plugged in 50 for here, and then add these two together because we know they're going to equal the same. Okay, so most of what we're doing is applying this formula on the homework, but practicing the little concave and convex, and a little bit of review for finding how many sides is going to be practiced as well. And that will be it for this assignment. And oh yeah, we have a little bit of practice on the transformations from a while ago. If you want to take out your, well, actually we have the notes sheet right here, just to practice this and make sure we remember it, because we have our final coming up in just about a month. Okay? All right, good luck.